Okay, in this question, we have a kettle that is being plugged in and switched on, and the fuse blows immediately. So this is most likely due to the current that is flowing through the live wire and the neutral wire is larger than the fuse rating. So this could be due to a sudden surge in the current. Okay, now let's look through the option. The earth wire is not connected to the kettle. Okay, whether the earth wire is connected or not connected, it will not cause a current surge. So this is not the answer. The live wire and the neutral wire connections are swapped around. Okay, so this will not cause a sudden surge of current as well because the current still has to pass through the resistance in the appliance. Option C. The live wire touches the metal casing of the kettle. Okay, this is the answer because when the live wire touches the metal casing, it bypasses the resistance in the appliance and it will just go straight down to the earth wire, which is a low resistance wire. So this will cause a short circuit and cause the current to surge and blow the fuse. This is the correct answer. Okay, let's just look at option D. The wires connected to the plug, they are too thin. Thin wire will increase the resistance, and the total resistance, if it's increased, it will cause the current to decrease. Okay, so this will also not cause a current surge. So the answer should be C. In this question, we have the current that is flowing from X to Y. Okay, and it is flowing at right angle to the magnetic field here. So there will be a force that is exerted on the coil, and to find out what is the direction of this force, we can use our Fleming's left hand rule. So the index finger should point to the right to signify the magnetic field, and the middle finger, it will represent the current, so it must be pointing upwards. And we have the thumb that represents the force. It is actually going into the paper. Okay, so as the coil here experiences a force that is into the paper, it will cause the whole coil to turn about the axis X and Y. So the answer should be D. We have a magnet that is moving into the coil. So an EMF and current will be produced in this coil. So using the Lenz's law, this EMF and current is induced in a direction such that it opposes the entering of the magnet. So meaning it will induce a EMF and current such that it creates a repulsion force so that it will push the magnet away. So how does this repulsion force looks like, right? It will be, if this is a north pole coming in, then you induce a north pole here to push it out. If it's a south pole, then you will induce a south pole here. Okay, so in this case, the coil will move to the left, which is away from the magnet. Okay, we have an ideal step-up transformer. So the ideal here is the keyword. It means that the power in the primary coil is equal to the power in the secondary coil. Okay, so the power in the primary coil can be calculated by multiplying the primary coil voltage with the primary coil current, which is 3 volt and 2 ampere. So this will be 3 times 2, 6 volt. So when we calculate the power of the secondary coil, we should also get 6 volt. Okay, so now let's find out which set of voltage and current reading are correct. We add in another column here. This will be our power. So using the formula, voltage times current, option A, it will be 1 times 6, we get 6 watt. Option B, 2 times 6, 6 watt. 4 times 1, 4 watt. Then option D, 6 times 1 is 6 watt. Okay, so option A, B, and D can be the answer. So now let's look at another keyword here. This is a step-up transformer, and you see that there are less turns on the primary coil compared to the secondary coil. So we look at the voltage. Initially is 3 volts, and for option A, the voltage decreases, so it cannot be the answer. And option B, the voltage also decreases, cannot be the answer. Only for option D, the voltage increases and we have a power that is 6 watts, that is the same as the primary coil. So D is the answer. This is a question on electronics and it has been out of syllabus since 2008. Okay, so this is a recall question. So if you look at the inputs and the outputs, there is only one gate that satisfies this criteria, and the answer should be C, NAND gate.